Now, in this lecture, we will find the diameter of the semicircle. In the drawing, we have a semicircle. The diameter of this semicircle is AB, and we also know that AD equals to 7 units, and also DC equals to 15 units, and CB equals to also 15 units. Again, AD equals to 7 units, DC equals to 15 units, and CB equals to 15 units also. And we want to find out the diameter of the semicircle or the size of AB. Okay, so first of all, we will make a construction. We will connect together points D and B by a straight line. And we will also define the center of this semicircle as point O. Again, point O is the center of this semicircle, that is this point. And then we will connect together points O and C by a straight line. And we will also connect together points O and D by a straight line. And first of all, angle ADB, this angle is a right angle according to rule number 1. Rule number 1 states that peripheral angle resting on the diameter of a circle equals to 90 degrees. Again, peripheral angle resting on the diameter of the semicircle of the circle, peripheral angle resting on the diameter of the circle equals to 90 degrees. So I will read rule number 1 again. Rule number 1 states that peripheral angle peripheral angle resting on the diameter of the circle equals to 90 degrees. And actually angle ADB, this angle is a peripheral angle that rests on the diameter of this semicircle, because angle ADB rests on AB, that is the diameter of this semicircle. Therefore, according to rule number 1, angle ADB equals to 90 degrees. Okay, angle ADB rests on AB, that is the diameter of this semicircle, of the semicircle, therefore it equals to 90 degrees. I will read again the things that I wrote. Angle ADB rests on AB, that is the diameter of the semicircle, therefore it equals to 90 degrees according to rule number 1. According to rule 1. Okay, so angle ADB equals to 90 degrees. So in the next step, we will focus on triangle ODC, that is the green triangle, and we will also focus on triangle OBC, the orange triangle, okay. We will focus on the green triangle and on the orange triangle. So in triangles ODC, the green triangle, and triangle OCB, on those two triangles, side DC of the green triangle equals to side CB of the orange triangle. Both those two sides are equal to 15 units in their sizes. So side DC of the green triangle equals to side CB of the orange triangle, and both of those two triangles equal to 15 units. And also OB is the radius of this semicircle, because it starts from the center of the semicircle and ends at point B, that is a point on the circle itself. Therefore OB is the radius of this semicircle. We will mark it as R. And also OD is also the radius of this semicircle, because it starts from the center of the circle and ends at point D, that is a point on the circle itself. Therefore OD is also the radius of this semicircle, and therefore OB equals to OD, because both of those two angles are the radiuses of the semicircle. So OD of the green triangle, side OD of the green triangle, equals to side OB of the orange triangle. Both of those sides are the radiuses of the semicircle. Okay, so OD in the green triangle equals to OB in the orange triangle, because both of those sides are radiuses of this semicircle. And also OC is a common side. It belongs to the green triangle, and it is also belongs to the orange triangle. So OC equals to OC. OC equals to OC. It is actually common side. Okay. So we actually proved that all the sides of the green triangle equal to all the sides of the orange triangle. Therefore, the green triangle DOC is congruent to triangle OCB. Okay, the green triangle OCD congruent to the orange triangle OCB, according to the rule that side rule. Side rule. That is to say, if you prove that all the sides of one triangle are equal to all the sides of the other triangle, then those two triangles are congruent to each other. Okay, so the green triangle is congruent to the orange triangle. Therefore, angle OCD, this angle, equals to angle OCB, according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so actually angle OCD equals to angle OCB. Those two angles are equal to each other. Again, according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so angle OCD equals to angle OCB. Those two angles are equal to each other. So if we define angle OCD as alpha, then angle OCB will be also equal to alpha because they are equal to each other. Okay, so both those two angles are equal to alpha. Okay, in the next step we will focus on triangle DCB. So in triangle DCB, side DC equals to side CB equals to 15 degrees. DC equals to CB. Both those two sides are equal to 50 degrees, 50 units. Okay, side DC equals to side CB. Again, side DC of triangle DCB equals to side CB. Both of those sides are equal to 15 units. And we have rule number 2 that states in front of equal sides in the triangle, there are equal angles. So I will read rule number 2 again. Rule number 2 states that in front of equal sides in the triangle there are equal angles. Okay, so according to rule number 2, we have in triangle DCB two sides that are equal to each other. DC equals to CB, and in front of side CB we have this angle ODC, and in front of this side DC we have this angle DBC. So actually, according to rule number 2, those two angles are equal to each other because in front of equal sides there are equal angles. So actually angle BDC equals to angle DBC. Those two angles are equal to each other, and if we define angle BDC as theta, then this angle that equals to angle DBC will be equal also to theta. Okay. Okay, so those two angles, angle BDC equals to angle DBC, and both those two angles are equal to theta. Then we will define this point as point E. this point is point E according to our definition. In the next step, we will focus on triangles CED and on triangle CEB. Okay, so in triangles CED, in triangle CEB, this triangle, so we actually focus on triangle CED and triangle CEB. Okay, those two triangles. Okay, actually side DC of the green triangle DEC equals to side CB of the orange triangle, triangle CBE. So DC of the red triangle equals to CB of the orange triangle. Both of those sides are equal to 50 degrees. This is given us in the question. And also side EC is a common side. It belongs to triangle DEC, and CED, it also belongs to the orange triangle, triangle CEB. So OC equals to OC is a common side. Common side. And this angle from the green triangle alpha equals to this angle of the orange triangle. This angle is also alpha. So angle DCE in the green triangle equals to angle ECB in the orange triangle. Okay, angle DCE in the green triangle equals to angle ECB in the orange triangle. Both those two angles are equal to alpha. Okay, so we actually proved that two sides, side DC and side OC, and the angle between those two sides are equal to sides OC and side BC and the angle between them in the orange triangle. Therefore, we proved that triangle DCE is congruent to triangle ECB. Triangle DCE, the green triangle, is congruent to triangle CEB, that is the orange triangle. Okay, triangle CEB is congruent to triangle CDE is congruent to triangle CEB according to the rule according to side angle side rule. According to side angle side rule. Okay, so those two triangles are congruent to each other according to side angle side rule. Actually, side angle side rule states that if you have one triangle, that two sides of that triangle and the angle between them are equal to two sides and the angle between them of the other triangle, then those two triangles are congruent to each other. Therefore, we proved that this side is equal to this side equals to this side, and this angle equals to this angle. Therefore, we proved that the green triangle is congruent to the orange triangle. Okay, so actually, therefore, angle CED of the green triangle will be equal to angle BEC of the orange triangle again. Angle CD, this angle of the green triangle, is equal to angle CEB of the orange triangle. This angle equals to this angle. Angle CED of the green triangle equals to angle CEB of the orange triangle, according to the rule that corresponding angles in congruent triangles are equal to each other. So if we define angle DEC as x, then angle CEB also will be equal to x, because those two angles are equal to each other. Okay, we defined angle CED that equals to angle CEB as x. Again, we defined angle CED that equals to angle CEB is x. And actually, because of the fact that DB is a straight line, actually we drew straight line between points D and B, so DB is a straight line. DB is a straight line. DB is a straight line. Therefore, if we focus on point E and on this side of the straight line, only on one side of this straight line, then the sum of the angles must be equal to 180 degrees, or triangle DEB must be equal, or angle DEB, this angle DEB must be equal to 180 degrees. Angle DEB must be equal to 180 degrees because of the fact that DB is a straight line. So in any point along a straight line, the sum of the angles at one side of that straight line at a certain point will be equal to 180 degrees. So DB is a straight line. Therefore, the sum of the points on the upper side of point E must be equal to 180 degrees. Okay? This angle plus this angle must be equal to 180 degrees. But we also know that angle DEB, actually angle DEB equals to angle DEC, this angle, plus angle BEC. Okay, the size of angle DEB is actually the sum of the two angles, angle DEC plus angle BEC. Okay, the sum of angle DEB is this angle plus this angle. But we know that angle DEC is defined as x, and angle BEC is also defined as x. So in total we got here x plus x, that is actually equals to 2x. So we found out that angle DEB equals to 2x. Okay, so here we can add that angle DEB also equals to 2x. Because we see here that angle DEB equals to 2x. So we have here equality that states that angle DEB equals to 180 degrees and also equals to 2x. So from this equality we can deduce that 2x equals to 180 degrees. Okay? From this equality we can deduce that 2x equals to 180 degrees. Okay, 2x equals to 180 degrees. So here we can divide this equality by 2 and we will get that x equals to 90 degrees. X equals to 90 degrees. Therefore, angle DEC, this angle that equals to x, is equal to 90 degrees. It is a right angle. Okay, so angle DEC is a right angle. It equals to 90 degrees. And also we found out that angle BEC that equals to x according to our definition also will be equal to 90 degrees. Okay, so we found out that two angles around point E are equal to 90 degrees. Angle BEC and angle DEC, both those angles are equal to 90 degrees. Now we know also that OC is the radius of this semicircle, because it starts from the center of the semicircle, that is to say from point E, and ends at point C, that is a point on the circle itself. Therefore OC is the radius of the semicircle. We will mark it as R. OC equals to R. Okay, OC is the radius of the semicircle, therefore OC equals to R. So from that we can deduce that OC is a straight line. Therefore OC is a straight line. OC is a straight line. Therefore we know that the sum of the angles along a straight line at one side of a straight line around a certain point equals to 180 degrees. So if we focus at point E, we know that the sum of the angles, angle CEB plus angle angle OEB must be equal to 180 degrees. Again, angle CEB, this angle that actually equals to 90 degrees, plus angle OEB, this angle must be equal to 180 degrees, because of the fact that the sum of the angles at one side of a straight line, if we focus at a certain point, must be equal to 180 degrees. Therefore angle CEB that equals to 90 degrees, we found that this angle equals to 90 degrees, plus angle OEB, plus angle OEB must be equal to 180 degrees. So we can subtract 90 degrees from this equality, and we will get that the value of angle OEB equals to 180 degrees minus 90 degrees is 90 degrees. Okay, so we found out that the value of this angle OEB, equals to 90 degrees. Angle OEB equals to 90 degrees. Again, I will repeat on the equality that states that the sum of the angles along a straight line, if we focus at a certain point at one side, must be equal to 180 degrees. That is to say, angle CB that equals to 90 degrees plus angle OEB must be equal to 90 degrees. We subtracted 90 degrees from this equality and we got that the value of angle OEB is 90 degrees. So here the value of this angle equals to 90 degrees. Okay, so we actually have around point E three right angles. This is a right angle, this is a right angle, and this is also a right angle. So around point E we have three right angles, and the sum of those three right angles is 90 degrees times 3 is 270 degrees. Okay, so the sum of the three angles around point E equals to 270 degrees. Okay, I'll write it down. The sum of the three angles around point E, around point E, is equal to 270 degrees. So I'll read it again. We already found out that the sum of the three angles around point E equals to 270 degrees. But we have a rule that states that the sum of the angles around any point equals to 360 degrees. Again, I write it down. The sum of the angles around any point is equal to 360 degrees. Okay, we have a rule that states that the sum of the angles around any point is equal to 360 degrees, and especially the sum of the angles at point E must be equal to 360 degrees. But we have already found out that the sum of those three angles around point E is equal to 270 degrees. So according to the rule that states that the sum of the angles around point E must be equal to 360 degrees, then the fourth angle must complete the sum of the four angles to 360 degrees. But we have already 270 degrees. So the fourth angle must be equal to 90 degrees in order to complete the sum of the angles around point E to 360 degrees. Therefore, in order to complete the sum of the angles to 360 degrees, the fourth angle must be equal to 90 degrees, and then we will get that 270 degrees plus 90 degrees equals exactly to 360 degrees. Therefore, we actually found out that all the four angles around point E equal to 90 degrees, are right angles. Okay? All the four angles around this point E are equal to each other, and they equal to 90 degrees. They are right angles. Okay? So, in the next step, we will focus on two triangles, on the big triangle, triangle ADB, and on the small triangle, triangle OEB. Okay, so I will draw these two triangles. So I will draw again triangle ADB and triangle OEB. So I drew again the big triangle, triangle ADB, and the small triangle, triangle EOD, triangle, the big triangle, triangle ADB, and the small triangle, triangle EOB. So in those two triangles, triangle ADB and the small triangle, triangle OEB, we have two right angles. Angle ADB is a right angle. In the big triangle, angle ADB equals to 90 degrees. And in the small triangle, angle OEB also equals to 90 degrees. So angle ADB in the big triangle equals to angle OEB in the small triangle. Both of those two angles are equal to 90 degrees. Angle ADB in the big triangle equals to angle OEB in the small triangle. Both those two angles equal to 90 degrees. We also have angle B, that is a common angle. Angle B belongs to the small triangle, triangle OEB, and it also belongs to angle to triangle ADB, that is the big triangle. Therefore, angle B equals to angle B, that is a common angle. Angle B equals to angle B, it is a common angle, it belongs to both triangles. Angle B equals to angle B. It is a common angle. And the third angle, that is actually angle ADB in the big triangle, will be equal to angle EOB in the small triangle. Those two angles are also equal to each other according to the third angle theorem. Okay? Angle DAB, this angle in the big triangle, equals to angle EOB in the small triangle, and those two angles are equal to each other according to the third angle theorem. According to the third angle theorem, those two angles are equal to each other. Third angle theorem. Okay, so those two angles are equal to each other according to third angle theorem. Third angle theorem states that if you have two triangles, the two angles of one triangle are equal to two angles of another triangle, then the third angle or the third pair of angles must be also equal between those two triangles. Why? Because it is complementary to 180 degrees. The sum of the angles in any triangle equals to 180 degrees, and the third angle must complete the sum to 180 degrees. Therefore, the third angle must be also equal between those two triangles. Okay, so that is the third angle theorem. So we actually found out that three angles, or all the angles in the big triangle, triangle ADB, are equal to all the angles in the small triangle, triangle OEB. Therefore, we actually proved that those two triangles are similar triangles. Therefore, triangle, the big triangle, triangle ADB, is similar to the small triangle, triangle OEB. Okay, therefore, triangle, the big triangle, triangle ADB, is similar to the small triangle, triangle OEB. According to the rule, according to angle, angle, angle rule. Angle, angle, angle rule. That is to say, if you prove that all the angles in one triangle are equal to all the angles in another triangle, then those two angles will be similar to each other according to angle, angle, angle rule. Okay, so from this similarity, the following relationship exists between the sides of those two triangles that are similar to each other. The relationship is actually states that OB over AB equals to OE over AD. Because of the fact that those two triangles are similar to each other, the following relationship exists between their sides. The relationship is that OB over AB equals to OE over AO. Okay, but what is the value of OB? What is the value of OB? Actually, OB is the radius of the semicircle, and also for the same reason also OA is the radius of the semicircle, because it starts from the center of the circle and ends at a point that is on the circle, and also here it starts from the center of the circle and ends at point B, that is a point on the circle itself. So OB is the radius of the circle. So we can substitute OB by R. And what is the value of AB? AB equals to R plus R. That is to say, AB equals to 2R. Okay, so OB over AB equals to OE over AD. And what is the value of AD? AD equals to 7 units. It is given us in the question. So in total, we got this equality that states that R over 2R equals to OE over 7. R over R is 1. So R is cancelled. R is cancelled. What is left here is 1 over 2 equals to OE over 7. So we actually found that one over 2 equals to OE over 7. So here 1 over 2 equals to OE over 7. Here we will multiply this equality by 7 in order to get the value of OE. And we will get that OE equals to 7 over 2 units. OE equals to 7 over 2 units. So here OE, that is OE, equals to 7 over 2 units. That is the value of OE. It equals to 7 over 2 units. And what is the value of EC? The value this is point E. The value of EC is actually equals to OC minus OE. Again, EC equals to OC minus OE. Okay, so EC equals to OC minus OE. Again, EC equals to OC minus OE. But what is the value of OC? As I already told you, OC is the radius of the semicircle. So EC equals to R. What is the value of OE? We already found out that OC equals to 7 over 2. 7 over 2. So in total, we got that EC equals to R minus 7 over 2. Okay, EC equals to R minus 7 over 2. So we can write here that EC, this line segment, equals to R minus 7 over 2 units. Okay. EC equals to R minus 7 over 2 units. So in the next step, we will focus on two right triangles. Triangle EOB. This orange triangle, triangle EOB, is a right triangle because of the fact that it has angle of 90 degrees. This is a right angle, therefore triangle EOB is a right triangle, and also triangle CEB is also a right triangle because it has one angle. This angle is equals to 90 degrees. So we have here two right triangles. in the orange color, so we can implement the Pythagorean theorem on those two right triangles. You should already notice to the fact that EB is a common side to those two right triangles, because EB belongs to the right triangle EBO, and also side EB belongs to the right triangle BEC. Okay, so we can write down that EB squared equals to EB squared. EB squared equals to EB squared. Okay, EB squared equals to EB squared, and we will use the Pythagorean theorem. EB squared will be related to this right triangle, and the other EB squared will be related to the other right triangles. So we will get that EB squared, if we relate to this right triangle, equals to OB squared minus OE squared. OB squared minus OE squared, and it equals to EB squared. EB squared equals to EB squared. So here the other EB squared will be related to the other right triangle BEC. So EB squared, if we relate to the right triangle BEC, it actually equals to CB squared minus EC squared. Equals to CB squared minus CE squared. Okay, so we got this equality. OB squared minus OE squared equals to CB squared minus CE squared. But what is the value of OB? OB equals to R, is the radius of the circle. So OB squared is R squared minus OE squared. What is the value of OE? OE equals to 7 over 2 units. So OE squared will be equal to 7 over 2 squared. All equals to CB squared. CB equals to 15 units, so CB squared is 15 squared. 15 squared is 225. Minus CE squared. CE, we've already found out that CE equals to R minus 7 over 2, so CE squared will be equal to R minus 7 over 2 squared. R minus 7 over 2 squared. So in total we got the following equality that states that R squared minus 7 over 2 squared, 7 over 2 is 49 over 4, equals to 225 minus R minus 7 over 2 squared. So we write down that 7 over 2 is 49 minus 4. Okay, we got that R squared minus 49 over 4 equals to 225 minus R minus 7 over 2 squared is actually R squared plus 7 over 2 squared is 49 over 4 minus 2 times R times 7 over 2 minus 2 times R times 7 over 2. Okay, so in total we got this equality. Here we have 2 in the numerator of this expression and we have 2 in the denominator of this expression, so we can cancel 2 and then we will open the brackets in this expression, and we will get that r squared minus 49 over 4 equals to 225 minus r squared minus 49 over 4 plus 7r. So here we have minus 49 over 4 in this side of the equation, and we have minus 49 over 4 in the other side of the equality, so we can cancel minus 49 over 4. And here we will add r squared to this equality, and we will get that r squared plus r squared equals to 2r squared equals to 225. R squared minus r squared is 0 plus 7r. Okay, in total we got that 2r squared equals to 225 plus 7r. Here we will subtract from this equality 225, and we will also subtract 7r, and we will get that 2r squared minus 7r minus 225 equals to 0. So actually we got here a quadratic equation, and actually the coefficients of this quadratic equation are a equals to 2, b equals to minus 7, and c equals to minus 225. So I write it down. Capital A equals to 2, capital B, the coefficients of this quadratic equation, equals to minus 7, and capital C equals to minus 225. Okay, those are the coefficients of this quadratic equation, and the solution of any quadratic equation, when the general formula of a quadratic equation is ax squared plus bx plus c equals to 0, when capital A, capital B, and capital C in this quadratic equation are the coefficients of this quadratic equation, and x is the variable of this quadratic equation that we want to find out the value of x, and we can solve this quadratic equation according to the following formula that states that the value of x, that is the variable that is missing in this quadratic equation, is actually equals to minus b plus minus root of b squared minus 4 times a times c over 2 times a. Okay, so that is the general solution of any quadratic equation, when x is actually the variable of this quadratic equation, but in our quadratic equation the variable of this quadratic equation is r. So x equals to r, x equals to r, so right here r equals to minus b, b equals to minus 7, so minus b is minus 7 is plus 7, plus minus root of b squared. B equals to minus 7, so minus 7 squared is 49. Minus 4 times a equals to 2, so 4 times 2 is minus 8. Minus 4 times 2 is minus 8. Times c is minus 225. Over 2a is 4. So in total we got that r equals to 7 plus minus root of 49 plus minus 8 times minus 225 over 4. So r equals to 7 plus minus 49 plus 8 times 225 is 1800. 1800 minus times minus is plus, so it is 1800 plus 49 is 1849. So in total we got in the root 1849 over 4. Okay, so the radius of the semicircle equals to 7 plus minus the root of 1384 equals to 43. So I write it down. So r equals to 7 plus minus 43 over 4. Okay, so in total we got that the radius of the semicircle equals to 7 plus minus 43 over 4. So here we will have two solutions for the radius. The first solution will be that r equals to 7 plus 43 over 4 equals to 7 plus 43 is 50. 50 over 4 is 12.5 units. So the radius of the semicircle equals to 12.5 units according to the first solution, but we have another solution. The second solution for the radius is r equals to 7 minus 43 over 4. 7 minus 43 is minus 36. Minus 36 over 4 is minus 9. So we got that the radius of the semicircle equals to minus 9, but it is impossible that the radius of the circle will be equal to a negative number. The radius of the circle must always be positive number. Therefore, this option is not true, is not correct. So we'll cancel this possibility and we're left only with the possibility that the radius of the semicircle equals to 12.5 units. Okay, it equals to 12.5 units, and we know that the diameter of this semicircle that equals to 2b, it actually equals to r plus r, that is 2 times the radius. Okay, again, the diameter of the semicircle equals to AB equals to r plus r. So 2 times the radius is 2 times 12.5, that is 25. So we found out that the diameter of the semicircle that equals to AB equals to 25 units. Okay, so we found out that the diameter of the semicircle that equals to AB equals to 25 units. Okay, so that is the answer to the question, that the diameter of this semicircle equals to 25 units, so AB equals to 25 units. Now I will summarize the lecture. Actually, we wanted to find out the diameter of this semicircle, and we know that BC equals to 15 units, CD equals to 15 units, and AD equals to 7 units. And we want to find out the size of AB, that is the diameter of this semicircle. It is also equals to 2 times the radius of this semicircle. First of all, we made the construction. We connected together points D and B by a straight line. And actually, angle ADB, this angle is a right angle because of the fact that it rests on the diameter of this semicircle, it rests on AB. Therefore, angle ADB equals to 90 degrees. According to rule number 1, it states that peripheral angle resting on the diameter of the circle equals to 90 degrees. So actually, this peripheral angle ADB rests on the diameter of this semicircle. The diameter is AB, and angle ADB rests on the diameter of the semicircle. Therefore, it equals to 90 degrees according to rule number 1. Okay. Then we define point E as the center of this semicircle. Then we connected points O and C by a straight line, and we also connected points O and D by a straight line. And in the next step, we focused on the green triangle and on the orange triangle. Side BC of the green triangle equals to side BC of the orange triangle. Both of those two sides are equal to 15 units. Okay, so DC equals to BC equals to 15 units. OD equals to OB. OD is the radius of this semicircle, equals to OB, that is also the radius. So side OB of the green circle equals to side OD of the green circle equals to side OB of the orange circle, because of both sides are the radiuses of this semicircle. And also OC equals to OC. OC belongs to the green triangle, and it also belongs to the orange triangle. Therefore, we actually proved that 3 sides of the green triangle are equal to 3 sides of the orange triangle, and therefore the green triangle is congruent to the orange triangle according to the rule of side rule. Okay, the green triangle congruent to the orange triangle according to the side rule. Whenever you prove that all the sides of one triangle are equal to all the sides of the other triangle, then those two triangles congruent to each other. Okay, then because of the fact that those two triangles can go into each other, this angle from the green triangle must be equal to this angle from the orange triangle, according to the rule that corresponding angles in congruent triangles are equal to each other. So angle OCD must be equal to angle OCB. Okay, so we defined these angles as alpha, and then we focused on triangle DCB, this triangle. On triangle DCB, side DC equals to side BC equals to 15 units. And we have rule number 2 that states that in front of equal sides there are equal angles. So in front of this side we have this angle, and in front of this side we have this angle. So those two angles are also equal to each other according to rule number 2. And we define this angle as theta, then this angle must be also equal to theta. And then we focused on the green triangle, triangle DCE, and the orange triangle, triangle CEB. Okay, on those two triangles, we know that DC equals to CB. Both those two sides are equal to 15 units. It is given us in the question. And OC equals to OC. OC is a common side because it belongs to both triangles. So that is the second side that are equal between those two triangles. And we also know that those two angles are equal to each other. So the angle from the green triangle are equal to the angle from the orange triangle. So we actually proved that two angles and the included angle of the green triangle are equal to two angles and the included angle of the orange triangle. Therefore, we actually proved that those two triangles, triangle CED and triangle CEB, are congruent to each other according to side angle side rule. Okay. So, because of the fact that those two triangles can go into each other, we can deduce that EB equals to ED according to the rule that corresponding sides in congruent triangle are equal to each other, and also angle DEC equals to angle CEB according to the rule that corresponding angles in congruent triangles are equal to each other. So those two angles are equal to each other. And we actually know that DB is a straight line because we constructed DB by drawing a straight line between points D and B. So DB is a straight line. And we know that those two angles are equal to each other. We define this angle as x. Therefore, this angle must be also equal to x because those two angles are equal to each other. So actually, along a straight line, if we focus at a certain point, the sum of the angles at one side are equal to 180 degrees. So angle DEB equals to 180 degrees if we focus on one side at point E. From one side, angle DEC equals to 180 degrees, but angle DEC also equals to x plus x, according to our definition. So, from one side, angle DEB equals to 180 degrees, and from the other side, angle DEB equals to 2x, according to our definition. So, from this equality, we can deduce that again 2x equals to 180 degrees. Okay, we divided this equality by 2 and found out that x equals to 90 degrees. That is to say, this angle is right angle and this angle is also right angle, because both those two angles are equal to x, and x equals to 90 degrees. And we also know that OC is the radius of the circle, therefore it is a straight line. And we know that along a straight line, at one side, if we focus at a certain point, the sum of the angles are equal to 180 degrees. Therefore, if we focus on this side of straight line OC and at point E, the sum of the angles must be equal to 90 degrees. So this angle that equals to 90 degrees plus this angle must be equal to 180 degrees. Okay, so angle CEO, this angle must be equal to 180 degrees. This angle, okay, CEO must be equal to 180 degrees because of the fact that OC is a straight line, and the sum of the angles at one side of a straight line at a certain point is equal to 180 degrees. Therefore, this is 90 degrees plus this angle must be equal to 180 degrees. That is to say, the angle that equals to 90 degrees plus angle OEB equals to 180 degrees. We subtracted 90 degrees from this equality and we found out that angle OEB equals to 90 degrees. So this angle OEB equals to 90 degrees. So we actually found out that the sum, we have around point E 3 right angles, and the sum of those 3 right angles equals to 90 degrees times 3 is 270 degrees. So the sum of the 3 angles around point E equals to 270 degrees. This angle plus this angle plus this angle equals to 270 degrees, but we have a rule that states that the sum of the angles around any point, and especially around point E, must be equal to 360 degrees. So we have here already 270 degrees, so the fourth angle must be equal to 90 degrees in order to complete the sum of the angles around point E to 360 degrees, because we have already 270 degrees plus the value of this angle must be equal to 360 degrees, and only if you add to 270 degrees 90 degrees, it will be equal to 360 degrees. Therefore, the fourth angle also must be equal to 90 degrees. So we actually found out that all the angles around point E are right angles, they are equal to 90 degrees. Then we focused on triangle ADB and on triangle OEB. I draw these triangles again here in this drawing. So in triangle ADB and triangle OEB, we know that those two angles are right angles, therefore they are equal to each other. We have a common angle. This angle belongs to the big triangle ADB, and it also belongs to the small triangle OEB. Therefore, angle beta equals to angle beta, that is a common angle. And the fourth angle must be also equal in those two triangles according to the third angle theorem. The third angle theorem states that if you have triangles that have two angles that are equal to each other, then the third pair of angles must be also equal in those triangles according to the third angle theorem, because the third angle is a complementary angle that completes the sum of the angles to 180 degrees. That is, the sum of the angles equals to 180 degrees in any triangle. Okay, so the third angle must be also equal. The third pair of angles must be also equal to each other. So according to the third angle theorem, so we actually proved that three angles in the big triangle, triangle AB, are equals to three angles in this small triangle, triangle OEC. Therefore, we actually proved that those two triangles are similar to each other according to angle rule. And therefore, we have the following: because of the fact that those two triangles are similar to each other, we have the following relationship between their sides. The relationship states that OB over AB equals to OE over AD. Again, OB over AB equals to OE over AD. Okay, again, OB over AB equals to OE over AD. But what is the value of OB? OB is the radius of the circle. And what is the value of AB? AB equals to R plus R, that is to say it equals to 2R. So we substituted OB by R and AB by 2R. OE stays OE. And what is the value of AD? AD equals to 7 units. So we got this equality. And from this equality, we found out that OD equals to 7 over 2 units. And what is the value of EC? EC equals to OC minus OE. Okay, EC equals to OC minus OE. But OC is the radius of the semicircle, and OE equals to 7 over 2. So in total we got that EC equals to R minus 7 over 2. And we have already found out that OE equals to 7 over 2. Then we actually have here two right triangles. This is a right triangle. Triangle CEB is a right triangle because of the fact that this angle is a right angle. And this is also a right triangle. Triangle OEB is a right triangle because of the fact that this angle is a right angle. So we have here two right triangles in the orange color. And we created the equality that states that EB square equals to EB square. The idea behind it that EB is a common side. It belongs to this right triangle, triangle ECB, and EB also belongs to this right triangle, triangle OEB. So we can operate the Pythagoras theorem on both those two right triangles, because EB equals to itself, it must be equal. Okay, so when we operated the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars on this right triangle, we got that EB square equals to CB square minus EC square. Okay, EB square equals to CB square minus EC square. And when we operated the Pythagorean theorem on this right triangle, triangle EOB, we got that EB square equals to OB square minus OE square. EB square equals to OB square minus OE square, but OB equals to R. So we substitute OB square by R square. OE equals to 7 over 2. So OE square is 7 over 2 square. CB equals to 225. CB square equals to 15 square, that is 225. And CE equals to R minus 7 over 2. Again, CE equals to R minus 7 over 2, so CE square is R minus 7 over 2 square. Okay, so we have arrive to a quadratic equation. By solving this equality, we arrive to a quadratic equation that states that 2r squared minus 7r minus 225 equals to 0. So the coefficients of this quadratic equation are a equals to 2, b equals to minus 7, and c equals to minus 225. And we have the formula for solving the quadratic equation to find out the value of the variable x. This is the formula in order to find out the value of x, but in our specific quadratic equation, the variable that is missing is the radius of the semicircle. So x equals to r, a equals to b, b equals to minus 7, and c equals to 225. The only thing that is left is to put the data inside this equality. And after we put the data, we found out that the radius of the circle equals to 12.5 units. And we have also the other solution that states that the radius of the circle equals to minus 9, but it's impossible because the radius of the circle must be a positive number. So this answer is incorrect answer. So we left only with the answer that the radius of the circle is 200.5 units, and the diameter of the circle is 2 times the radius, that equals to AB. So the diameter of the circle, D is abbreviation for diameter, that equals to B equals to 2 times the radius, is 25 units. Again, the diameter of this semicircle, that equals to AB and equals to 2 times the radius of the semicircle, equals to 25 units. Okay, thank you very much.